So let us see the design of concurrent and real-time software architectures. So before we go to this particular architecture, let us see the characteristics of the real-time systems. Hope I am audible to all of you. Okay, so the real-time systems are the concurrent systems with timing constraints. Okay, so there are strict timing constraints on the real-time system, like if user has in the user interaction, the response from the system, of course it should be the correct, but there is a time limit as to how much is the response time for that particular system. They have widespread use in industrial, commercial, and military applications. Okay, so these are the typical areas in which this particular real-time systems may be deployed or it may be used. The term real-time system usually refers to the whole system, including the real-time application, real-time operating system, and the real-time I/O subsystem with special purpose device drivers to interface the various sensors and actuators. Okay. So the real-time system, it refers to the the complete system, mm, uh, which involves all the sensors or actuators in certain greenhouse system. There can be the sensors like temperature sensors, humidity sensor, and all that, and based on that certain actions are taken, and uh, the actuators like the pump or fan or heater coolers, so they need to be operated. uh, Sometimes these particular actions, they are very critical. For example, there may be or there is likely to be overflow if the level sensor is going to detect certain level, and based on that, if certain uh, actuator output is to be generated, then the response time of the system should be very quick, and it should give signal to the actuator so as to uh, close certain wall or close or shut off some pump, so that the level will not cross that particular uh, limit, maximum limit. Okay, so response time should be within the limit for such systems. Uh, so this is typically a real-time system, the deployment diagram for the real-time system. So you have number of sensors in such system. So here they are labeled as sensor 1, sensor 2, sensor 3, up to n number of sensors can be there in that particular system. So your real-time system will shall be receiving the inputs from these particular sensors. It is concurrent in the sense that it is not just monitoring only what is happening at sensor 1 or what is happening at sensor 2, but concurrently or simultaneously it is monitoring all the sensors, and depending on what input it is received from a particular sensor, or the number of sensors, based on that the real time system is going to make certain decisions, or it is going to process those particular inputs from the sensors, and immediately within the stipulated period of time, it generates the outputs for the actuators. So like you have n number of sensors, so there can be n number of the actuators, and this particular actuators, it may be certain wall, it may be certain pump, it may be certain uh, device like tube lights, or it may be a certain cooler or heater, and like that. Okay. So these particular devices are either to be put on or put off. Sometimes this particular input is in discrete nature. Sometimes you need to convert it into continuous form, and it may be not be only putting on or off the fan. It may be the speed of the fan. Same thing applies to the heaters or cooler. So the speed at which the heating is done or speed at which the cooling is done can also be controlled by just instead of giving just two inputs in the form of on or off, it can be in the discrete number of levels form also. Okay. So this is the general, you can say, the architecture of such real-time systems which need to work concurrently uh, on the various inputs, and concurrently the outputs are to be generated. Okay. So the systems, they can be of this particular systems, concurrent systems, real-time systems. They can be of different types. So you can have a centralized control architectural pattern, or you can have some different pattern for it. So if it is centralized control architectural pattern, in that there is one control component which conceptually executes a state chart and provides the overall control and sequencing of the system. The control component uh, receives events from other components with which it interacts. These include events from various input components and user interface components that interacts with the external environment. For example, through sensors that detect the temperature of the environment, or the other components such as the output components, which output to the external environment, for example, to the switch actuators on and off. Entity objects are also used to store any temporary data needed by other objects. Okay. So like this, in the centralized control, you have some centralized component which receives the inputs from the sensor components, and in turn the outputs are generated, or actions are generated, which are forwarded to the output components, and in these output components, they actually output it to the external environment. So putting on and off certain devices in your system. Okay. In addition to this, you can have the entity components even. So it may be some temporary storage data. Some data need to be stored, and as per that, certain decisions based on that, certain decisions are to be taken. So the data will remain there for the time your system is executing, or it may be a period of time over which that particular data need to be maintained, and after that, that data uh, may change, and depending on that, correspondingly the required output, it will change. Okay. So it may be, so that data may be certain configuration that is expected by the user. So that particular configuration, for example, it may be, most of the time in industrial process it is automated process or manual process, or it may be having different modes of operation, and the user is going to select one or the other modes. Okay. So the centralized control architectural pattern can be specified in this particular form. Okay, uh, the constituent components in such centralized control architecture pattern may look like this. For example, this is the uh, centralized control architectural pattern for a particular system, in which the input components being the door component, the weight component, the keypad component. Okay, so the microwave control shall be receiving the inputs from these particular components. Okay, whereas this particular particularly which particular input they will be giving, or they are going to generate various events. Typically the door component is going to generate the event that is send control request. Okay, so the door event, that means either it may be a closing of door or opening of the door. So this particular event is generated, and it is sent to this particular micro controller. Whereas as far as this particular weight component is concerned, then it's sends a message that is send control request, and wait event. Based on the wait event, it will be generated. So probably the change in the weight of the, the food stuff that is kept in the microwave controller or microwave, if it changes, then this particular event may be generated. Then the event that may be generated by the keypad compartment is whenever user is going to press any key, so that key event is generated, and then a message will be sent to this particular microwave controller for processing that particular key. Okay, so that is as far as the input units are components are concerned. Whereas the output components being the heating element component. Okay, so microwave oven shall be having heater in it, and then start cooking. So, and the label is also mentioned, and it may be giving another message that is stop cooking after a certain period of time. So like this, the messages are being sent by the control component to this particular output component. The other output component being microwave display. So the status of the microwave oven, it may be displayed on this particular microwave display. So whatever data is received, so display prompt, whatever data is received from this particular microwave control component, so that will be sent, that the data to be displayed on that particular monitor or display of this particular microwave oven, it is sent to this particular component, and this component will in turn will get it displayed on that particular dashboard of you can say this microwave oven. Okay, so like this particular system, it has got many input components and many output component, and the most important part is the in such system the control is centralized. Okay, so this particular control, that is every device is going to, or every input you can say component is going to work in coordination with this particular centralized component. Okay, the second architecture of for such real-time software architecture, it can be a distributed control architectural pattern. So the distributed control pattern contains several control components. Each of these components controls a given part of the system by conceptually executing a state chart. Uh, Control is distributed among the various control components with no single component in overall control. Okay, so here there is no master, or no one is slave, and uh, typically every component is given some part of the system to be controlled. It may be receiving the inputs from some only from some part, but this particular that particular component, though it is associated with a particular part of the devices, but on their own they do not take the decision, and whatever inputs have been received, so those particular inputs, they are sent for the to the other components. So to notify each other of important event, the control component communicate through peer-to-peer communication. So usually that particular communication is peer-to-peer communication. So all the components which are there in a particular group, so that they take part in this particular computation. So they also interact with the external environment as in the centralized control pattern. Okay, so typically you can see here the distributed control architecture consists of several control components. Okay, so in case of the central component, there was a single control component, whereas here there are many control components. The input and output components, they are connected to one control component or the other control component. Okay, so all the input component and output control component, they are not connected to a single control component like in case of the centralized control architecture. Okay, now even if certain inputs are certain events are received by a particular control component, but the important events, they are sent to the other control component. Okay, so consider that this particular control component, they form some ring type of structure, and whatever important event they receive, they pass it on to the next component. Okay, so the connection between the control components is usually the peer-to-peer connection, and using this particular peer-to-peer connections, all the components, they are connected to each other in some cyclic fashion, or in you can say the circular queue fashion. So events, they move, or even even if it is not in circular fashion, uh, the thing is that they form certain change, and that particular event, important event, propagate on from one control pattern to the another control pattern on that particular chain. So this is the uh, you can say the architecture for the distributed control type. Okay, then even you can have the third type of the control architectural pattern, and it is known as the hierarchical control architectural pattern. The hierarchical control pattern, also known as multi-level control pattern, contains several control components. Okay? Each component controls a given part of the system by conceptually executing a state machine. In addition, a coordinator component provides the overall system control by coordinating several control components. The coordinator provides high-level control by deciding the next job for each control component and communicating that information directly to the control component. The coordinator also receives status information from the control component. Okay, so this is how is the arrangement that is made in case of the hierarchical control architecture. Okay, so in this particular, it is a mixture, you can say, of the earlier two discussed control architectural patterns. Okay, so here the actual controlling of the devices uh, is given to the various components, like the distributed control, whereas the as far as taking certain decisions are concerned, so it is not taken individually, or you don't need to, or the coordinate, you don't need to coordinate among all the components. Okay, so many times that becomes very hectic in the sense, when many people are involved in making the decisions, then it takes time to make those particular decisions. And as you are aware, or as it is one of the requirement in the real time system, that the response time should be very less. Okay, so here you can see this particular control components, they control the input and output. Okay, so each of the control component, they control the input and output. Okay, whereas they do not send the important event for discussion among the remaining components, but there is another hierarchical controller, and the important events, they are sent to this particular hierarchical controller. Then this particular hierarchical controller, upon receiving the request from or responses from each of these particular control components, okay, which are the events which have occurred at different inputs. So based on that, it takes the decision and it sends the command to each of the of this particular control components. And this particular, that means only one component is involved in actual decision making, okay. Of course, certain decisions, the low level decisions, they can be taken at this particular level only, okay. The important event, they are passed here, but certain low level decisions, they are taken at this particular level, that is this particular component level, in which the other inputs are not required or other actuators are not involved. So based on that, certain decisions, low level decisions, they are taken at this particular level only, whereas the higher level decisions, they are taken at this particular level, that is hierarchical control, okay. So that is why it is referred to as the multi-level control architectural pattern, okay. So also called the hierarchical control architectural pattern, okay. So this is about the different architectural patterns that are available for the real-time software architectures, okay. So I hope you have understood the three different methods that we discussed for this particular uh, design of the concurrent and real-time software architectures, okay. Hello. हाँ सर. हाँ. हाँ. काय म्हणतो सर? आपल्या डिपार्टमेंटकडनं लास्ट टाइम किती रेव्हेन्यू जनरेट झाला होता? किंवा रेव्हेन्यू मिळाला होता आपल्याला? रेव्हेन्यू जनरेट झाला होता. नाही, तो ते तुमच्याकडे जे झाला होता ना, तर तोच आहे ना तो. हा, बाकी ऍडिशनल दुसरा कुठला नाहीये. हा. हा. नाही नाही नाही. ओके. Hello. So there was interruption. Whether I don't know whether the connection was lost or not. So for today we shall stop here. I hope all of you have marked your attendance.